Alright, this is the last lesson of this chapter, and we're going to talk about a shape that we haven't talked at all about yet. We're going to talk about a sphere. And as you can imagine, there are lots of spheres out there in the real world, anything from sports like soccer balls and baseballs and basketballs to the fact that we live on a huge sphere. The formulas we're going to use today all apply to really big things out in the real world. So first off, what is a sphere? A sphere is the set of all points in space equidistant from the center. So it's like the circle definition just stepped up a notch. We can go in all directions the same amount of space, and that's how a sphere is created. So a couple of parts we need to talk about. The radius is the segment that goes from the center to a point on the sphere. So this guy here is the radius, but the radius could also go this direction, it can go this direction, it can go towards us, which is hard for me to draw right now, but it can go in any direction from the center, and that's considered a radius. And then the other term that you need to understand is what it means to be a great circle. A great circle is the biggest possible circle that you can draw in a sphere. So we have two different circles that are drawn in here. This is the biggest one. That is what's called a great circle. Also, you'll see that it has the same center as the sphere. What's important about that is what we can actually use to figure out the surface area and volume of an actual shape. If you think about, for instance, like a tennis ball right now, we are not going to be able to take a tennis ball and measure its radius because we can't physically see its center, but we can measure its great circle, and that'll help us to then work backwards to find the radius, and we're going to look at an example of that a little bit later. What I need you to realize about this other top circle up here is that's not a great circle because it's not the biggest. Okay? And then the last piece, if you look at this bottom picture down here, that is half a sphere right now. I would ask you in class what you think the name of that is. And then I would reference you to thinking about what we call half the globe. Half the globe is actually called a hemisphere, which is what this is called. It's not a semisphere like a semicircle, but it's called a hemisphere. Okay? And then we're going to do a quick video right now about how to find the surface area of a sphere. So this video is just going to show you a quick demonstration using an orange. Notice she cut the orange in half, creating that great circle that we talked about. So those have the same radius as the actual sphere right now. And she's taking the orange peel, which would represent the surface area, that's the area of all the surfaces, and filling in. Look at how many circles get filled in. There are 4 circles, and think about what the area of a circle is. Fuzzy Wuzzy was a bear, area equals pi r squared. So the surface area of a sphere actually ends up being 4 pi r squared. Okay? And then I filled in the volume formula for you already. That one's actually the weirdest formula we've seen out of all of them. It's 4/3 pi r cubed. So when we get to that first example in the notes, I'm going to show you on your calculators how you're supposed to type that in. So looking at number 1, we just want to find the surface area. So the surface area formula from the last page was 4 pi r squared because we can make 4 circles. The radius is just 7, so we're going to do 4 pi times 7 squared, and we are going to leave these in pi form. So you just need to type in 7 squared times the 4 in your calculator, and you should get 196 pi. This is now back to surface area, so make sure you're putting square units on your answers. It's yards squared because we're doing area. And then in number 2, same formula, 4 pi r squared. This time they did not tell you the radius, so make sure that the number you're using is the radius. The radius would be 12.5. So it's going to be 12.5 squared. And then again, I'm just letting the calculator type everything in but the pi, so we can leave it in pi form. And this is 625 pi inches squared. Okay? Alright, number 3, we're finding volume. So first off, the formula is 4/3 pi r cubed. Make sure you keep that as a 3, not as a squared. We are so used to squaring the radius, so you need to make sure you're thinking about that differently. So for this first example, it's going to be 4/3 pi times 9 cubed. So how I want you to type that in your calculator, I want you to do, for the 4/3, do 4 divided by 3, and then you have to do times 3, And then you're using the caret button, which is right above the squared button. And you're going to do to the third power. I'm going to show you a picture of what my screen looks like right now. So now you see that's what it should look like on your calculator. And that tells you that the answer is 972 pi. This is now volume, so we're going to do meters cubed. Okay? So now let's try number 4. So we know that the formula is 4/3 pi r cubed, but we need to make sure we're using r. R this time is 7.5. So it's going to be 4/3 pi times 7.5 cubed. And then I need you to type that in your calculator to see what you get. You should get 562.5 inches cubed. Oh, pi inches cubed. Okay? Alright, the last two problems we're going to look at are more real-world problems. So the first one is, what if we wanted to know the surface area of a baseball? So instead of them giving us the radius, which you can't measure because you can't like cut, I mean you could, but you don't want to cut a baseball in half just to figure out what the radius is. So instead we could measure around the circumference and get that great circle. But what we need to realize here is if I want to find the surface area formula says 4 pi r squared, is I still need to find the radius. So this is actually going to take us back to chapter 10 when we talked about circumference, and we actually have to start with that formula first. So twinkle, twinkle, little star, circumference equals 2 pi r. We're going to have to use that formula and use the fact that they told me that the circumference is 9.25, and we're going to plug that in. So it's going to say 9.25 equals 2 pi r. And then we have to solve for the radius. So the first thing we need to do is divide by 2. We get 4.625 is equal to pi r. And then we'll divide by pi. And you get the radius is equal to, run around to 2 decimal places in the middle of this problem. We're going to put 1.47. And now we can go over and say, I know the radius now. I can take that and plug it in to find the surface area. But we had to work with the circumference formula first. So I can plug in 1.47 squared. And since this one is a real-world problem, we're actually going to put the pi in the calculator too. So type the whole thing in, 4 pi times 1.47 squared. And then you should get 27 point, we're going to round to the nearest tenth, 2 inches squared would be the surface area of a baseball. Okay? And then number 6, we are talking about a ping pong. It says a ping pong fits snugly inside a cube that's 40 millimeters on each side. What is the amount of empty space left in the cube after the ping pong ball is put inside? So I'm going to fill in. We know these are 40 millimeters since if it's a cube means it's equal on all 3 sides. So we know it's 40 by 40 by 40. And we need to know the empty space. So the key to this is actually we have to find the volume of 2 things, because the empty space is a weird shape. It's that leftover space. So we're going to have to find the volume of the cube, and we're going to have to find the volume of the sphere to figure out how much space is there. So the fact that it said space, that's how I know I'm doing volume. So volume of a cube, we actually had a shortcut formula on the day I taught you this. It's just side cubed. So we can do 40 cubed to figure out what that volume is. And that is 64,000. And then to find the volume of the sphere, we're using the new formula from today, 4/3 pi r cubed. But I need to figure out what the radius is right now. So looking at where the 40 is, the 40 would actually measure all the way across the ping pong ball. All the way across would be 40, which means the radius is really 20. So it's going to be 4/3 pi 20 cubed. And again, because this is a real-world problem, I'm going to put the pi in right away. I'm going to do 4 divided by 3 times pi times 20 cubed. And that's going to turn into 33,510.32 And then to answer the question, they want to know the empty space. So the empty space, to get that, we have to subtract those two values. So to find this empty space, I'm doing the outside shape, which was the cube, minus the inside shape, which was the sphere, and subtracting to get my final answer. And you should get 30,489 we'll round it to the nearest tenth now, 7 millimeters cubed, since we found the space, the volume. You guys have a couple quick problems on Class Kick to do, and then your homework assignment. Please try the word problems on the homework assignment. I expect to see some effort, at least trying at least one formula for each problem. Don't leave them blank. Okay? Hang in there, guys. We are almost to the end of the week. Oh, and you will have an in-class assignment tomorrow, so just as a heads up, in case I hadn't said that yet, I want to make sure that that's clear, that there'll be an in-class assignment tomorrow on what we've learned this week.